This is a magnet. They come in many different shapes and sizes, like these little circles, this bar, and even this U shape. The Earth itself is even just a big magnet. Magnets. How do they work? First of all magnets are made out of metals. This means inside their atoms, they have a limited number of valence electrons orbiting its nucleus. This means when these atoms bond together, they form a sea of electrons. In this sea of electrons, the electrons are constantly moving around inside of it. This then forms a magnetic field around the metal, turning it into a magnet. This magnetic field then has a force that pulls on other ferromagnetic objects, such as iron or nickel. But not your everyday metal can be a magnet. This is because groups of atoms are called magnetic domains. Normally, these magnetic domains are pointing in many different directions. Each individual magnetic domain has its own magnetic field, but since they're not aligned in the same direction, these cancel out, creating a very weak magnetic field. But when all these domains are aligned in the same direction, then their individual magnetic fields are also aligned, creating a much stronger and more powerful magnet and magnetic field. With the stronger magnetic field, there are also stronger poles. These two poles, conventionally called north and south poles, are oppositely charged from each other. This is where we get the phrase, opposites attract and likes repels from. When two opposite poles are placed next to each other, such as a north and south pole, they will start to attract to each other. But when two magnets with opposite poles are placed next to each other, such as two north poles, they will start to repel each other. As previously mentioned, not all metals start out as magnets though. Most metals can turn into magnets through a process called magnetization. This is where we take a magnet and rub it against a metal. We can use an object such as a nail or a screw to complete this process. When we rub this magnet against this nail, we align the domains of this nail to point in one direction. This then creates a strong magnetic field around the nail, turning it into a magnet. This is only one way to magnetize a metal though. Another way to magnetize a metal is through a process called
electromagnets. Like your everyday metal, wires with electricity with them also have a slight magnetic field too. This is because, like metals, they have a field of free-flowing electrons. These free-flowing electrons are able to create the magnetic field. Now, this magnetic field here is pretty weak, but if you coil the wire, it becomes much, much stronger. But then again, even this is still pretty weak. Now, when you add a metal, like your everyday nail, for example, inside the coils, the magnetic field is extremely strong. This right here is called an electromagnet. Now, by itself, this nail would have no magnetic field at all. That's because the magnetic domains inside of it are not aligned. Instead, by adding the coil around it, the magnetic domains are pulled in a direction, aligned in this direction, making the strong magnetic field. Now, this is pretty interesting, but I'd love to talk to you about some examples. But instead of talking to you about these examples, I'm going to show you. What's poppin', Patterson gang? So now we gotta go to Home Depot and grab some of our electromagnetic supplies.
Shut up.
So a simple metal like this screw does not have its domains aligned. Therefore, it has a weak magnetic field and is not able to attract any paper clips. Now, when we attach a copper wire in a battery, we can create a small magnetic field, as I stated earlier, aligning the domains in the screw. And now we are able to attract paper clips. Now, as you can see, there are not that many coils of copper wire around the screw. So the magnetic field is still fairly weak. We can only pick up like what, 1 to 2 paper clips? Now, when we add more coils to the screw, we're able to pick up many more paper clips, around 4. This is because, as I stated earlier, we have more coils which stack more domains, creating a stronger magnetic field in the wire, which aligns more domains in the screw itself, which overall just creates a stronger electromagnet.